Hello students, today we will be going over H2.6, using matrices to solve systems of equations. Our objective, I can solve systems of linear equations using matrix row reduction, including identifying special cases. Solving an augmented matrix is similar to solving a system of equations using elimination. The goal is to produce a 2x3 matrix where the first two columns are an identity matrix, where it's a cross going 1, 0, and 0, 1. We're on page H38. Operations that produce row equivalent matrices. Okay, we can interchange row 1 and row 2. We can multiply by a non-zero constant, and we can also, a constant multiple of one row is added to another row. Replace one equation by the sum of it with another. Like you multiply something by row 2 and you add it to row 1 to get a new row 1, something like that. So here it goes through an example, but I think just going through and doing an example that you have to do is kind of more teachable that way. So we're going to go on to the next page, on page H39. So we're going to solve this system of equation using matrices. We have x plus y equals 2 and x minus y equals 6. Step 1, we need to get 1 in the A11 position. So let me go ahead and write our reduced augmented matrix. So again, you write it here without your x and your y. You just write the coefficients. So we have 1 in front of x, 1 in front of y, and I'm going to do a dotted line and 2 for the answers here. I think in the other way, they don't put anything there, but I like the line there to show that these are what the answers are. The next one, there's a 1 in front of x, there's a -1 in front of y, and we have a 6. Now, we can manipulate these numbers till we get the identity matrix, which will be 1, 0, 0, 1, and then whatever's left over here will be your solution. So the first step, step 1, is to get a 1 in the A11 position. So right here is the A11 position, and there's already a 1 there. So we don't need to worry about that. So I'm just going to rewrite it. So 1, 1, 1, -1, and then 2 and 6. Okay. Step 2, get a 0 in the A21 position. So right here, we need to get 0. And this is the A21 position. So how do we do that? Well, if I multiply the top row by -1, add it to the second row, that will give me a new row that has a 0 in the A21 position. So -1 times row 1, I'm going to rewrite that over here. -1, -1, -2. So I multiply -1 by the whole row. Now I have 1, -1, and 6. And when I add the two together, I'm going to get 0 for the first one. And that was our goal. 0, -2, 4. Okay. So that is going to be our new row 2. So we have row 1, still with 1, 1, 2, and 0, -2, 4. Okay. The next step is to get a 1 in this position. So what we can do is just divide everything of this row by a -2. Or the way they do it, multiply -1/2 times it by row 2 and make that a new row 2. So if I divide everything, just row 2, divide by -2, that will give me my new matrix here of 1, 1, 2, 0, 1, -2. Okay, so now we have 1, 0, 1. So we almost have our goal. The goal is to get 1, 0, 0, 1, and then get our solution, whatever is left over there. So the next thing we have to do is to multiply -1. Sorry, this is like lengthwise, so okay, so -1 times row 2 plus row 1, and it will be our new row 1. So if I go -1 times row 2, I'm going to go ahead and write that right along here. -1 times row 2 is 0, -1, and 2. So I multiplied row 2 by -1, and I'm going to add it to row 1. If I add that together, I get 1. 1 minus 1 is 0, and then 2 plus 2 is going to be 4. So that will be our new row 1, will be 1, 0, 4. Hopefully you can still see that okay. And we leave the bottom the way it is, 0, 1, -2. Okay, so the next part is our solution, which if you have 1, 0, 4, we know x is equal to 4. So we can say x equals 4 and y equals -2. So we go ahead and put it in ordered pair form, and we put 4, -2. And there you have the solution. Okay, I know it's kind of weird, so again, going back up to the top, you want 1 to be in this position, manipulate things from row 1 to get 0 right there. Once you have 0 there, you go over here to make that 1, and then we go back up there to make that a 0. So it's kind of like you do a U. To get that 1, this 0, that 1, that 0, and then whatever's left here will be your solution. The top one will be x, and the second one will be y. Okay, so let's go ahead and practice some more, because I know this is hard. Okay, so we have 2x minus 3y is 1, x plus y is 13. So if we have our matrix here, augmented matrix, again, you take your x and your y out. I guess maybe I don't need to put that dotted line there. So, all right, step 1, get a 1 in the A11 position. So we need this one. What we're going to do is this 2 needs to be a 1. So we're going to flip-flop. And it's okay to switch row 1 and row 2. So our new matrix is 1, 1, 13, and 2, -3, 1. Okay, next we want to get this to be 0. So to make that 0, we're going to multiply the top by a -2. Because we know -2 plus 2 is going to be 0. So if I take the top and multiply by -2, I'm going to get -2, -2, and -26. So my new row 2 is going to be 0. Again, I'm taking the second right here and adding it to this one. And this is going to be -5, and that's -25. Okay, so again, it shows -2 times row 1 plus row 2. That's just what I did here. So now we have 1, 1, 13, and 0, -5, -25. Okay. Now we need to get a 1 in the A22 position. So what we're going to do here is divide this by -5, or we're going to multiply it right here by a -5. or negative 1/5. So to me, it's the same as dividing by negative 5. So to do that, I'm just going to go, divide by negative 5 right here, divide by negative 5, divide by negative 5. So again, that's the same as multiplying by negative 1/5. My new matrix is going to be 1, 1, 13. We didn't do anything with the top row. The next one is 0, 1, and 5. Okay. The next thing we have to do is get a 0 in this position, the 1, 2 position. So in order to get a 0 in that position, we're going to go negative 1 times row 2 and add it to row 1. So if we multiply this whole thing by negative 1, I'm going to get 0, negative 1, negative 5. And I'm going to add that to 1, 1, and 13. And that will be our new row 1. Okay? So 0 plus 1 is 1. Negative 1 plus 1 is 0. 13 plus negative 5 is 8. And this 0, 1, 5 will stay the same. Okay, so it tells us that x is 8 and y is 5. So x equals 8 and y equals 5. And again, you put it in ordered pair, 8, 5. Okay. All right, students, you can do the rest of these. There's just a couple more problems there. And you rock!